Well, this is the part two. In this problem, we're going to check how can we use the other equations. A solution of ethanol and water has a film. What's the meaning of film? Well, imagine that you have water and oil, okay? You have two things that are not miscible, that are immiscible. So we have a layer, this little layer that separates all the things. This one has a thickness of 2 millimeters, okay? That is dividing water and ethanol. They are in contact with an organic solvent that is diluted in ethanol but not in water. So if this part tells us that diluted in ethanol but not in water, is going to tell me that we don't have a consideration of diffusion because it's not going to happen. So knowing this situation, we're going to leave apart the part of the water. So this one is going to become zero, but the one that we want to know is for the ethanol. Knowing this, the concentration is 16.8% weight the solution, and the density is 972.8 kilogram per meter per cubic meter. This is the concentration that we're going to find in one situation, okay, in the part A. In the part B or the part 2, the ethanol is 6.8 and the density is 988.1 kilograms cubic meter. Knowing this situation, we know that in one part, this is the part 1 and this is the part 2, knowing that situation is easy to know that in the part 1 we have a concentration of 60.8. In the next part we only have the concentration of 6.8. Well, knowing the situation, let's going to start doing the exercise. It's telling us that the fraction of A in the part 2 is a concentration of 6.8. 6.8 of what? Of ethanol. The ethanol that we have is 6.8. 6.8% of what? We have to transform the percent into grams, into a fraction. We're going to transform the fraction to a molar part. Okay, we're transforming. Remember the last exercise that we did? In that exercise, we worked the molar part when we want to know only the grams, not the moles. So in this case, we're going to work that situation. The weight of the ethanol is 46. So if we transform the situation, we're transforming the first part. As we know, we want to know the fraction. The fraction we're going to transform is 6.8 divided by 46.05. And what's this number? Well, this one is if I have the 100% minus 6.8, we're going to have 90.302. That's the situation. That's why we have this value in here, because we have the concentration of water. This is the part of water that we have in here. Okay, remember that in here we have 6.8 of ethanol. The other part is going to be the water. It's going to happen in the same situation in the part 1, where we're going to have 16.8, and the other part that we're going to find in here is going to be, we're going to do the simple operation. We're going to have the situation of 83.2, right? So we're going to have the 83.2 in there. So we're going to do the same considerations. When we divide this, we're going to obtain this. When we divide this, we obtain this, and we obtain this. If we do the same for the other, we're going to obtain for xa1, xa2, xb2 is going to be 1 minus point, and we obtain the result. But first of all, we already obtained xa2. Yes? The operation is going to be given the fraction of the first part. That's the fraction that we have consideration in considering all the details. Now, if we do the same situation in your notebook, you're going to do the same. You're going to look for xa1. Well, with this operation, we're going to obtain the value of xa1 and xa2. To obtain xb2, well, it's simple. We already know a2. The other part that we're going to have in here is b2. So 1 minus the other part, the part that we obtain, is going to give us the 0.9723. That's the result of xb2. If we want to know xb1, we're going to do the same. 1 minus 0.0732. Well, in that situation, we're going to obtain the result of xb1. Well, going to the next part, we're going to do some other considerations. Well, the other considerations that we're going to have are simple. We have to calculate m. Before we can start doing everything, we have to calculate m. But how do we calculate m? Well, m, we have a calculus base that is going to be 100 kilograms. And we already know the weight that we have in each part. We have the weight of each situation. And in this case, we're going to measure the first consideration. We're going to measure the first part of m. And we're going to do exactly the same to know m1 and m2. It's going to be 100, but these details, where can you find them? Okay, remember the details that you're going to look for in the first part. Okay, so you have to look for the result of m1, that it's going to be 2007, and m2 is going to be 18.75. This one, you have to look for it. Okay, in your notebook, you're going to look for that detail. The same as xb1, you have to look for that detail. Okay, you have to complete the exercise. Now, we continue. We already checked xb1 and xb2, xa1 and xa2. Also, we already checked m1 and m2. And the last detail that we have to do is we have to consider the fraction. We're going to have the densities, and this detail is going to give us a result of, we already know the densities, okay? We have the density of the first part, 972.8 plus 988.1 divided by m1, that it's 20.07 and 18.75. Also, this one is also, all those things are divided by 2, and we're going to obtain the result of everything is going to give us a result of 50. Okay, let's think about, because maybe you're going to find a result that is going to be pretty similar. 49, 51, it's okay. When we already know this detail, we already know the concentration, okay? Remember that this is how we measure the concentration, the final concentration. Now, we already have all the details. We already have all the details to answer the problem. Remember, Na is going to be, now, we already have the diffusion coefficient. Another thing that we have to measure is the concentration. We already have the concentration. Then we need the fractions of A1 and A2. Okay? The fractions are of the part A. All those things are divided by what? Okay, we have to look for the fraction of Bm. The fraction of Bm is going to be given by 0.949. Okay, do the operation to look for 0.949. Also, we have the distance. The distance that we have is, we're transforming. This one is in meters. The one that we have in here is millimeters, so we're only transforming. And we're going to multiply by the xbm. We're going to multiply by this one. And this one is going to give us a result of 8.9 to the minus 7. The units. What units we're going to obtain? Well, that's for you. That's for homework. You have to complete all the details of the problem. Yes? Okay, thank you so much, guys. See you the next class.